Hello everyone. So this is the solution of worksheet of lecture 2. So I'm going to start by the first exercise. In this exercise, we need to find the Cartesian equation of the straight line D. This straight line, it passes through the point A and it has S as a directing vector. So first of all, as I always tell you, to find the Cartesian equation, you should have two vectors. One of them is the directing vector, and the other belongs to the straight line. I only have one point that belongs to the straight line D, so I'm going to create a point M. It has coordinates x and y. And now I'm going to have the vector AM and the vector S. They are collinear, so we apply the rule of the determinant that says that xy prime minus x prime y is equal to 0. So after doing this, we're going to get this equation, which is 2x plus 3y plus 5 equal to 0. So keep in mind, you should have two vectors. One of them is the directing vector, and the other belongs to the straight line. In part B, I have a straight line D that passes through 2 points only. So from those 2 points, I should create two vectors. One of them is the directing vector, and the other belongs to the straight line D. So AB is the directing vector, and AM belongs to the straight line D. And also those two vectors are collinear, so we apply the rule of determinant, and this is the Cartesian equation. In part C, what I know that is that straight line D, so it passes only through a point A, and it has a slope -2 as a directing coefficient, which is the slope. So this is very easy. We apply, as we learned in grade 9, y equals ax plus b, and I replace the point A and the directing vector. In this case, I'm going to get the value of b. And this is the equation y equal -2x plus 4, but this is in the reduced form, so I need to make it Cartesian, so I just bring them all before the equal. Okay, now we have a straight line D passing through A, and it's parallel to the straight line D prime. You should always remember that if two lines are parallel, then they have the same directing vector. So the directing vector of D prime, which is -BA, is 1, 2. And it's a directing vector for D prime also. So now the straight line D, it has a directing vector V and a point A. So how do I continue? I create the vector AM, and V are collinear, and we apply the determinant. This is the Cartesian equation. Okay? So just to summarize this exercise, every time you need to make the Cartesian equation, you need two things: a directing vector and a vector that belongs to the straight line, and you apply the determinant that says xy prime minus x prime y equal to 0, and that's it. Okay? Now, question or part B, I need to give the parametric representation of the straight line D. In the first case, I have a point and a directing vector, and this is very easy. You just put the form, which is x equal -2t minus 1, where you put the directing vector as a coefficient of the parameters and the point A beside the coordinates, okay? Beside the parameters, as you see. In part B also, we have 2 points A and B. So I need to create a directing vector, which is AB, or BA, as you want. AB, which is -1, 3. And then we replace those coordinates as a coefficient of the parameter, and you can replace the point A or the point B beside the parameter. So it's either 3 - 1 or 2, 2. Both of them are correct. Now D passes through A and admits a directing vector, a directing coefficient as slope. So first of all, you should find the equation of the straight line, which you know, as we did in the question part A. And then after that, you have this reduced. How do you change from reduced into parametric? You just take x equals any parameter, which is t. You replace it in y, and you will get the y in terms of t, as you see. Okay? Now in part D, D passes through the point A, and it's parallel to D1. If they are parallel, then they have the same directing vector, which is -1, -2, the coefficients of the parameter, and then we create the parametric equation as you see. Okay? Now in part C, I need to check the straight lines are parallel, confounded, or secant. Excuse me. So I have D1 and D2. First of all, I need to change D2 into Cartesian form and not reduced form. And you start checking the values. First of all, u over u prime is 1 over -1, which is -1. V over v prime is -1 over 1, which is also -1. And w over w prime is -4 over 4, which is also -1. So we knew now that d1 and d2 are coincident or equal or confounded because all these values are equal. In the second case also, I'm going to find u over u prime, which is 1 over 4, v over v prime, which is also 1 over 4, and w over w prime, which is also 1 over 4. So the two straight lines are coincident or equal. Look at the third case. U over u prime is 1 over 2, and v over v prime is 1 over -1. So they are not equal. So directly we say that they are secant or intersecting. Now, what if I have parametric equations and I need to check if they are parallel or intersecting? So first of all, I'm going to find the directing vector of each straight line. And I'm going to do the dot product, and it's not 0, so they are parallel. While in the second one, I'll make the dot product of the two directing vectors, it's equal to 0, then we say that they are intersecting or orthogonal. Okay? And now let us solve a complete question. In question number 2, we have a system OIJ and 3 points A, B, and C. We need to find a Cartesian equation of the straight line delta that passes through A and of directing vector OC. So it's very easy. We already have the directing vector OC. I need now to create a vector AM, which is x minus 1, y plus 2. And you know that AM and OC are collinear. So we apply the determinant, and this is the equation of the straight line delta. 2x minus y minus 4 equals to 0. Now we need to do the parametric form of the straight line of BC. So BC, I have 2 points. First of all, I should find a directing vector, and then you replace this the coordinates and the coefficient of the parameter, and you can replace the point B or C beside the parameter. Now write a system of parametric equation of the straight line D prime passing through the point M and parallel to D double prime. You know that if two lines are parallel, then they have the same directing vector, and then you can replace it in the parametric equation as you see in this form. Now calculate the distance from B to delta. You should remember that the distance is equal to the absolute value of uxb plus vyb plus w over radical x squared of b and y squared of b. So you just replace them, and the distance is going to be 1 over 3. Now, in question number 3, we have a straight line DM. DM means it's in terms of m, and m belongs to real number, and we have a straight line D in the parametric form as you see. Determine the direction form of DM. The direction form of DM is minus BA, so it's minus 3 plus m, 2m minus 1, so it's in terms of m. In number 2, you need to determine the value of m in each of the following cases. If dm is parallel to d, then they have the same directing vector, but you should first convert d into a Cartesian form and then find its directing vector, because d it's in the parametric form and dm in the Cartesian form. So the first step you have to do it is to change d into Cartesian. How? You do t equals x plus 1 over 2 and t equals minus 1 plus 2. You put t equals to t, so you will get this form, and this is the Cartesian form of straight line D. Now what's the directing vector of this equation? It's minus 2, 1. And now minus 2, 1, it's equal to the directing vector of dm, which is minus 3 plus m, 2m minus 1. So you just take, for example, -3 plus m equals -2, and then m equals 1. If you replace the y coordinate, you are also going to get m equals 1. Let us continue. And now we have dm is parallel to y prime oy. If the straight line is parallel to y prime oy, then the y is equal to 0. So I just take the y out here from the coefficient of y, which is 3 minus m. It should be 0 because there is no y. So you take 3 minus m equals, or m minus 3 equals 0, then m equals 3. Okay? Now dm cuts d at a point of abscissa -1. So dm and d, they intersect at a point. This point, it has an abscissa -1. So I'm going to replace -1 in d to find y, and then replace x and y, which is -1 and 2, in dm, as you see. So instead of x, you are going to put -1, and instead of y, you are going to put 2, and you are going to get m equals 13/11. And that's everything in our worksheet.